Hello, everyone. In this lesson, we will discuss polymer concentrated solutions. The learning objectives of this lesson are: 1. To understand the concept of polymer concentrated solutions. 2. To know the industrial applications of polymer concentrated solutions. Polymer solutions are generally classified into dilute and concentrated solutions. Solutions with a weight concentration below 5% are considered dilute. Those greater than 5% are concentrated solutions. For example, the concentration of spinning solutions is typically between 10% and 15%. Paints contain about 60% solids, and polymer plasticizer blends have even higher concentrations. They may become semi-solid or solid. Industrial applications include solution spinning in the fiber industry, for example, acrylic fibers. Plasticizers in the rubber and plastics industries, such as PVC plasticized with dioctyl phthalate, and the formulation of paints, coatings, and adhesives. Definition: to modify the processing or functional properties of certain polymers. A certain amount of high boiling point, low volatility small molecules, or flexible polymers is often added. These substances, which increase polymer plasticity, are called plasticizers. Their main function is to lower the glass transition temperature and to increase fluidity and elasticity. Classification: first, phthalate esters; second, phosphate esters; third, glycol and glycerol esters; fourth, adipates and sebaceates; 5, fatty acid esters; 6, epoxies; 7, polyesters; 8, others, such as chlorinated paraffins, chlorinated biphenyls, and acrylonitrile butadiene copolymers. Polymer and plasticizer examples. Polyvinyl chloride, PVC, is plasticized with dibutyl phthalate, DBP, or dioctyl phthalate, DOP. Nitrocellulose, plasticized with DBP or castor oil. Cellulose acetate, plasticized with DBP or triphenyl phosphate. Polymethyl methacrylate, plasticized with DBP. Natural rubber, plasticized with mineral oil or coal tar. Plasticization mechanism: nonpolar plasticizers dissolve in nonpolar polymers, increasing the distance between high polymer chains, weakening the intermolecular forces, and reducing friction between chain segments. Thus, the larger the plasticizer's volume, the greater its shielding effect. For polar polymers, strong interactions between polar groups or hydrogen bonds create many physical crosslinks between molecular chains. When plasticizers penetrate between the macromolecules, their polar groups interact with the polymer's polar groups, disrupting these physical crosslinks. This allows chain segments to move. In fiber processing, melt spinning, for example, nylon, polyester, and solution spinning, for example, PAN, PVA, PVC, AC, and C. Requirements for spinning solution solvents. First, a good solvent. Concentration varies for different products, typically between 15% and 40%. Second, a moderate boiling point. If the boiling point is too low, solvent loss is high, and rapid evaporation during forming causes poor fiber formation. If too high, it's hard to remove from the fiber. Third, non-flammable, non-explosive, non-toxic. Fourth, inexpensive and readily available, easy to recover, and the recovery process shouldn't degrade it. Paints are also polymer concentrated solutions. When a polymer solution loses fluidity, it forms a gel. A physical gel forms through crosslinks via van der Waals forces. Heating can disrupt these crosslinks, causing the gel to dissolve. There are two types of gels. Intramolecular physical cross-linking leads to globular polymer chains. The chains cannot extend, resulting in low viscosity. This results in highly concentrated solutions, 30 to 40%, with low viscosity. If such a gel solution is encountered during spinning, due to the molecular coiling, the chains are not easily oriented, resulting in low-strength fibers. If intermolecular physical cross-linking forms, a gel with an intermolecular stretch chain structure is formed. It has high viscosity. Heating can convert an intramolecular gel into an intermolecular one. This increases the solution's viscosity. Thus, for the same high polymer at the same concentration, viscosity can vary widely. Different processing methods can yield two distinct types of gels, or a mixture of the two. A chemical gel is a swollen network where chains are cross-linked by chemical bonds. It cannot be dissolved or melted by heating. It is both a concentrated polymer solution and a highly elastic solid. Small molecules can permeate and diffuse through the gel. Most biological organisms are based on chemical gels. They are strong enough to hold shape, yet soft. They also allow metabolism, excreting waste and absorbing nutrients. Summary. First, concentrated solutions have a concentration greater than 5%. Second, key uses: polymer plasticization. For example, using dioctyl phthalate for PVC, solution spinning of PVC, processing fibers like PAN, PVA, PVC, AC, and NC. When a high polymer solution loses fluidity, it forms a gel.